Hello everyone. In this video, we're going to be solving a beautiful equation, a problem from Romania. Now this problem, I'm not exactly sure about the resource, but I think it was in a book that was written for algebra problems in Romanian. And I just saw this and I'm like, this is a beautiful problem. All right, great. If you're from Romania, go ahead and comment and let me know what you think. We have 2 to the power x plus 3 to the power x plus 6 to the power x equals 4 to the power x plus 9 to the power x plus 1. That's a mouthful, right? So we're going to be solving for x values, but we have a lot of exponentials. And guess what? The bases are all different, which makes this problem super duper interesting. Great. Now, obviously, you can do some guess and check, but you also need to prove those are the only solutions you find, or prove that there are no other solutions, or maybe there are infinitely many solutions, right? But it's pretty interesting because we're using different bases and we're getting an equality like this one. Great. Let's go ahead and get into the problem. Now, there's probably a way to look at this problem from an increasing, decreasing function perspective by dividing everything by some type of a to the power x, but I'm not exactly sure how that's going to work. So that method, if you have any ideas, please let us know in the comment section down below. But the method I'm going to show you is actually pretty cool for these kinds of questions because it takes this exponential problem and turns it into something else, which I'll show you right now. Okay, so we're going to use substitution, obviously. That's one of my favorite methods, maybe the best one. We have 2 to the x, 3 to the x, and 6 to the x. Just looking at the left-hand side, what can you tell would be a good thing to substitute, right? And we can use more than one, obviously. So notice that 6 is 2 times 3. So 6 to the power x, in other words, can be written as 3 to the power x multiplied by 2 to the power x. So that gives us a good clue. And again, this problem is from Romania. Holler if you are from Romania. Okay, great. So let's go ahead and take a look. We have this interesting scenario where we have 2 to the x plus 3 to the x plus 6 to the x equals 4 to the x plus 9 to the x plus 1. The only issue here is that we don't have something to the power x, but that's perfectly fine. Here's what we're going to do. We're going to go ahead and set 2 to the power x equal to a and 3 to the power x equal to b. And obviously 6 to the power x is just going to be the product of these two things, right? What about 4 to the power x and 9 to the x? If you look at it carefully, you're going to realize that, hey, this is the same thing as a squared because 2 squared is equal to 4, and this is the same as b squared. And of course, 1 is going to stay as is. Okay, so far so good? Great. Now let's go ahead and see how we can use substitution. But since we have higher degree terms on the right-hand side, let me go ahead and write that on the left-hand side. So we're going to switch sides here and write this again in terms of a, b. A squared plus b squared plus 1 is equal to a plus b. And of course, we already talked about it, but this is equal to a times b, which is ab. Now, at this point, this may not look meaningful to you, right? Like, what are we going to solve for, right? Well, one of the ways to approach this problem, which you can definitely pursue, is going to be writing it as a quadratic. And it's quadratic in a and b, so you kind of have to make a choice. And maybe you can do something like, hey, let's write it as a quadratic in b. Okay, so let's do that. And by the way, this wasn't planned, but I think this might lead us somewhere helpful or fruitful. That's why I'm going to explore this method first. So let's go ahead and call this first method because for both of these methods, I'll be using the same type of substitution. Okay, great. So that was the intro. Now, let's go ahead and put all the b and a terms on the same side. So kind of like this. Set equal to 0. My goal is to write this as a quadratic in b, so I wrote the b squared first. And I'm going to be looking at the terms with b in them, so their coefficient is going to be a plus 1, right? So I've taken care of those two terms. And then at the end, I'm going to have a squared minus a plus 1 equals 0. Now notice that this was written as a quadratic in b, especially if you kind of focus and highlight these b terms, right? So how can we solve it? Well, a quadratic equation can be solved with the quadratic formula. So now you can write b equals negative b, which is the, by the way, it's a little confusing here because the coefficient of b is considered b, but in this case, it's in terms of a, okay? But you get the idea, the opposite of this term here, plus minus the square root of that thing squared, but minus sign is not going to make a difference. Minus 4 times 1 times the constant term. Of course, when you're writing something as a quadratic in, B, then everything else is considered a constant, okay? And of course, the coefficient of b squared is 1, so it's going to be divided by 2. Great. Now, how is this going to help us? I don't know yet, but one of the things that I'm going to be looking at is going to be the discriminant, which is the expression under the radical. So let's go ahead and call that delta, Greek letter delta. For discriminant, some people use uppercase D. Same idea. Notice that they're very similar, right? Some people say, isn't this a triangle? No, it's Greek delta. Okay? That's where we get our D from, probably. So delta is going to be a squared plus 2a plus 1. And then from that, we're going to, that looks like an h, which I don't like, minus 4a squared plus 4a minus 4. Great. Now, let's simplify this a little bit. Delta equals, this will give us a negative 3a squared plus 6a minus 3. Now, you're probably looking at this like, what the heck is going on? I got the delta, but it's a quadratic in A, right? Well, you start with a quadratic in B, and its delta is a quadratic in A. How cool that can be, right? So one thing to keep in mind, though, this is a special expression. If you dealt with polynomials before, you should know that factoring out negative 3 would be a good thing. Why? Because if you factor out a negative 3, inside you're going to get a squared minus 2a plus 1. Uh-oh, that looks familiar, doesn't it? Well, it is a perfect square, so I can now write it as negative 3 times a minus 1 quantity squared. Of course, this is not a coincidence. This problem is probably from a math competition or math contest. That's why it's been designed that way, which some people call contrived. Such a bad word, right, for this. Especially designed for math competitions or curated, whatever. Now, what does this delta tell you? Well, something squared cannot be negative. If it's multiplied by a negative, then it cannot be positive. So in other words, this expression is less than or equal to 0. Uh-oh. Houston, we have a problem. We want the 2 to the x and 3 to the x to be real, unless you're dealing with complex numbers. But of course, this channel doesn't always deal with complex numbers because I have another channel called aplusbi. Go ahead and check it out. That completely deals with complex numbers and problems associated with them. Go ahead and check it out and let me know what you think, but that's definitely a good channel that you should be looking at. Now, this expression is less than or equal to 0, so if I want real solutions, I don't want my delta to be less than 0, because delta less than 0 means no real solutions, right? From a quadratic polynomial perspective. I don't want that. This is not good, so what I want is delta to be 0. Uh-oh. That's a good thing. I want delta to be 0, which means a is equal to 1, right? Great. So we got a single value from an inequality. Beautiful. Sometimes we solve equations with inequalities and equations with inequalities with equations, something like that. Anyways, I can't even say it. But you get the idea. We start with an equation. We find the delta, and then the delta is a quadratic, and we look at the delta of the quadratic. Anyways, this is too confusing. You get the idea, hopefully. A equals 1. Okay, what does that mean? If a is equal to 1, then you can just plug it in and find the value of b, can't you? Okay, let's go ahead and take a look. What's our equation? A squared plus b squared plus 1 is equal to a plus b plus ab. Let's go ahead and plug in a equals 1 and see what happens with b. 1 plus b squared plus 1 is equal to 1 plus b plus b. Okay, so one of the ones cancel out. We get b squared plus 1 is equal to 2b, or not 2b, that's the problem. B squared minus 2b plus 1 is equal to 0. Uh-oh, Houston, here we go again. We got the same idea. From here, b is also 1. So a equals 1, b equals 1 is the only pair of solutions that'll work in the real case. But what is that supposed to mean? What is a? A is 2 to the power x, remember that. If 2 to the power x is equal to 1, this means x is equal to 0. If 3 to the power x is equal to 1, this means x equals 0. X equals 0 and x equals 0 tells you for certainly, right? Certainly that x equals 0 is the only solution for this equation. Why? Because we cannot find any other real solutions from an equation like this. But wait a minute, this is not the only way to solve the problem, right? Absolutely not. So let's go ahead and take a look at this problem from another angle, which I call the second method. Are you ready? So we have a squared plus b squared plus 1 equals a plus b plus ab. Okay, we looked at, so let me summarize what we did with the first method. We wrote it as a quadratic in b and looked at the discriminant, and in order to get real solutions, delta had to be 0. From there we found a, by substitution we found b. You could also write it as a quadratic in a, nothing would change, because as you can see here, they're perfectly interchangeable. Great, now, let's go ahead and look at it differently. I'm gonna go ahead and actually put everything on the same side, okay? A squared plus b squared plus 1 minus a minus b minus ab equals 0. I'm not going to write it as a quadratic. I'm going to treat it differently. Now, here's what we're going to do. We're going to multiply both sides by 2. Of course, 2 times 0 is 0. So from here, we get 2a squared plus 2b squared plus 2 minus 2a minus 2b minus 2ab equals 0. Again, you might be wondering, why on earth would you do something like that? I had some viewers before. I can't remember his name is, I think, Leif, something like that. He always asked, like, why on earth would you do that? That's how you solve problems, okay? And you learn that through experience. But anyways, so after multiplying everything by 2, I can kind of split up terms, which I wasn't able to do before. For example, I can split this into a squared plus a squared. This can be split into b squared plus b squared. And then, of course, that'll help us pick some terms, like, for example, I can use one of these a squared and then pick minus 2a, and of course split this into 1 plus 1 and just use 1. And then I can take one of the b squares and then pair it up with 2b, which is minus 2b, and then use the other one. So this is used, this is used. What do we have left? We have a squared, b squared, and 2ab. You connect the dots, a squared minus 2ab plus b squared. And guess what this gives you? This gives you a sum of 3 squares. Let's take a look. This is a minus 1 squared plus b minus 1 squared plus a minus b squared. Now, if you're looking for real solutions, again, we are looking for real solutions because a plus bi is for the complex cases. But in this case, for the real case, if the sum of 2 or more squares is equal to 0, then each term has to equal 0. Because if one of them is positive, the other one has to be negative, which is impossible. Proof by contradiction, everything has to be 0. So this is 0, this is 0, and this is 0. Guess what that gives you? That gives you a equals b equals 1, and that's the only conclusion you get from here, which means x equals 0 is the only solution to this system. And what was the system? 2 to the x plus 3 to the x plus 6 to the x equals 4 to the x plus 9 to the x plus 1. And again, thank you to Romania for this beautiful problem, and keep them coming. Let me know if you know of any other equations like this one, because I'm curious. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out SyberMath and aplusbi. And until next time, bye-bye.